Hey there, this is going to be the final review for quarter 4. If you have any questions, please feel free to reach out. And we're going to go through each question one by one. You can skip to whichever problem you need. So to begin with, number 1, write the following using exponents. Remember the number that or letter that's repeated is my base, so m. And how many are there? There's 3 of them, so m to the 3rd power. G is being repeatedly multiplied, so G, how many are there? There's 5, so to the 5th power. And that would be my answer. Number 2, evaluate the following expression. That we can do using a calculator. Now, 4 times 4 times 4 times 4 times 4 is equal to, tell me what it's actually equal to. So 4 to the 5th power, 4 to the power of 5, is 1,204. So 1,024, pardon me. And that is my final answer. Make sure you get the number form, not just the written out form. Evaluating 10 plus 3 to the 4th power. Remember to use order of operations, parentheses, exponents, multiplication and division come at the same time in addition and subtraction. So don't do that addition first. Make sure you do the exponent. So clearing that, 3 to the power of 4 is 81. So 10 plus 81 gives me a grand total of 91, and that would be my final answer. All right, continuing. Simplify, write with positive exponents. Remember, with negative exponents, that they are unhappy where they are. It's kind of like they're at war and they're spies on the wrong side. So this fraction bar determines where they're going to go. This y to the negative 2 is going to go to the denominator, so y. And because it's now on the right side, it's going to be positive. And I'm going to cross that off the top. This negative 4 and z moves to the north side. So z to the 4th power loses its negative, and it's where it wants to be. And remember, zeros simplify to 1. So my final answer is going to be x to the 5th power, because that's not going to move, z to the 4th power over y to the 2nd power. And I leave off that 1 because to simplify, we don't need it. All right, simplify. And we're going to write with positive exponents. So remember, if there's not an exponent, it's an imaginary 1. So I have 1, I have 4, and I have 3 more. So if I combine them all together, I have 8. So x to the 8th power. Remember, we can add our exponents. 1 plus 4 is 5, plus 3 is 8. Now, if I simplify this expression, one thing to be careful of is do not add those numbers. Hey, they are not the same base to be repeatedly combined. I'm just going to do that multiplication. 3 times 5 is 15. And then I'm going to write down my rest. So I have x to the 3rd, x to the 2nd, and x to the 3rd again. I have y to the 9th and y to the 3rd. I'm going to combine my x's and I'm going to combine my y's. So I simplify to 3 plus 2 is 5 plus 3 is 8. So x to the 8th. And 9 plus 3 is 12. So 15, x to the 8th, and y to the 12th. If I'm looking at my next problem, you'll notice that I've got x to the 5th and y to the 3rd inside the parentheses and just a random 3 outside. We're saying the parentheses is to the power of 3. So I'm repeating what's inside the parentheses 3 times. So 5, 5, 5 gives me a total of 15. 3, 3, 3 gives me a total of 9. Hey, or remember I can multiply. 3 times 5 is 15. Whoops, 15, not 5. And 3 times 3 is 9. So this is my simplified answer. Simplify this expression. And I want positive exponents. As I look at my fraction, remember, I've always got things that are going to battle, and if they're the same variable, that's what's directly going to cancel each other out. If I have 8 y's on top and 3 y's on bottom, 3 of them are going to cancel on top, 3 of them are going to cancel on bottom, and how many is going to be left out of the 8? I'm going to have 5. Remember, the trick is to do subtraction. Y to the 5th. Now, for the z's, what I want you to make sure you notice is that there's more z's on bottom. So if they go to battle, the bottom's going to win. Z's are on bottom. 7 minus 3 is 4. And that's my simplified answer. Simplify this expression. So I've got a very similar problem except for one thing. I noticed that I have a negative exponent, so move it first. I'm going to move it to the top. I'm going to just rewrite it. A to the 5th, B to the 7th, and B to the 5th over A to the 2nd. And as I simplify, I can see that I get, well, what's going on with the A's? They're going to war, and I have 3 left on top of my fraction. B's not going to war, but combining forces, and I have 12 of them. Now you'll notice there's nothing left in the denominator. There's an imaginary 1, but simplified form says to erase that and just write A to the 3rd power and B to the 12th. Simplify the following expression. So I'm going to go ahead and, since I have 2 fractions, I'm going to combine them all together first. So remember to multiply the numbers in front to begin with. So 15, A3, B8, and I'm going to pause a second. I'm going to bring that other B next, B4 and C9, all over C4 and A10. I'm going to simplify everything on top that I can, and it looks like these B's are going to combine forces. So I have 15, A3, B12, C9, and I have C4 and A10. Now let's continue. Now that the top and the bottom are simplified, and I can't simplify anything else, I'm going to look at each term separately. So 15's good. I'm going to leave 15. A's, there's A's on top and on bottom. There's more on bottom, so A goes on the bottom, and there's 7 more. So 7 goes A to the 7th power on the bottom. I look at the B's, that's all that there is, so B to the 12th stays on top. And then there's C's. Now there's more C's left on top, and how many? There are 5. So my answer, 15, B to the 12th, C to the 5th, divided by A to the 7th. All right, so again, very first thing I always do is I move any negative exponents. If they're unhappy, I'm going to move them. So that's gone off the top, and I have a y to the 3rd on the bottom. Now I have 2 different fractions, so let's combine all of our forces. I have 9 to the 3rd, y to the 2nd, y to the 3rd, y to the 7th, and x to the 2nd. Now simplify the top. It's simplified. Simplify the bottom. Oh, I can combine the y's. That makes 10 of them. Now that the top and bottom are simplified, they go to war. If I look at the x's, there's more x's on top, and 7 would be left over. If I look at the y's, there's more y's on bottom, and there would be 8 left. So my answer is x to the 7th divided by y to the 8th. Scientific notation. So I'm got to identify whether these following numbers are in scientific notation. Remember, to be in scientific notation, I've got a number, and this number has to be smaller than 10, but bigger than 1. So, has to be not a decimal, it can't be bigger than 10. So, and it also has to be times 10 to the something power, it doesn't matter. As long as this is 10. So as I look at my first example, this 12 is bigger than 10, not smaller. So this is not scientific notation. That is bigger than 10, smaller than 10 and bigger than 1. And this does have 10 to the something power. So this is scientific. So I look at my next example, smaller than 10, bigger than 1. That has the power of 10. We're good, scientific. Last but not least, that works. Smaller than 10, bigger than 1. But as I look at this, notice this is a 4. It has to be 10 to be a scientific notation. So this is not scientific notation. Convert the following number from scientific notation to standard form. So remember to convert into standard form. What I am trying to do is I'm trying to get rid of the times 10 to the negative third power. If you have times 10 to the negative third power, this means this is a decimal answer. Negative exponents mean a decimal answer. So how do I move my decimal point so that I get a decimal? I got to move it to the left, and this tells you how many spaces. 1, 2, 3 spaces. So 0.0043, and I'm going to slide an extra 0 in front of that decimal point. On the other hand, if I have a positive exponent, that means I'm going to have a large number. So I want to move my decimal to the right. I want to move it this way. So I'm going to move it 5 times. There's 1, there's 2, there's 3, 4, and 5. And those blank spots are filled with 0. So I have 8, 4, 2, 0, 0, 0. Converting numbers back to scientific notation. So remember, I need a number that's smaller than 10. Smaller than 10, bigger than 1. Okay, times 10 to the somethingth power. Now this is a decimal answer, so I am going to tack a negative on there to begin with, and I'm going to move my decimal point. 1, 2, 3. Now where do I want my decimal point to end up? I want a number that's bigger than 1. So if I leave it there, it's going to be smaller than 1. It's going to be 0.5. If I move it one more, I'm going to have 5.3, which is bigger than 1 and smaller than 10. So I'm going to move it there. Fill in that blank spot. 5.3 times 10 to the negative power. How many times did I move that? Let's count again. 1, 2, 3, 4. So negative 4th power. Convert this number to scientific notation. Now this is a really large number, so you're not going to write the plus sign in your answer, but it's going to be a positive. Where's my decimal to begin with? Right here at the end. Where do I want to move it? Oh, I want a number that's bigger than 1 and smaller than 10. So as I move it, I don't want to move it here because that's still too big. I don't want to move it here. That's 52. I'm going to move it right here in between the 5 and the 2. So let's count 1, 2, 3, 4, 5, 6. So my answer is going to be 5.2 because I include all of the numbers to the times 10 to the power of 6. All right, now that we've talked about adding, converting back and forth, let's talk about our operations. So remember, in order to add or subtract, my 10 to the something power has to be the same. If I multiply or divide, they can be different. So when I'm adding or subtracting, these need to be the same. So this and this need to be the same. And in this case, they actually happen to be. Once they're the same, all I have to do is go in front of that times 10. So 8, I have 8.3, and I want to minus 2.2 of those. So 8.3 minus 2.2 is 6.1. So 6.1 times, now this is the trick, don't combine your exponents. It's kind of like terms, you just leave them the same. So times 10 to the 4th power. Now what do I do when they're not the same? I have an addition problem and these are not the same. You have to make them the same, and I always make them match the larger number. So since this is the smaller number, I want to increase this to 8. That means I'm going to add 1 to that, which means I'm going to move my decimal place and compensate. Since this is 1 bigger, I want to make this 1 smaller. So by 1 smaller, I mean move my decimal 1 time. So I have the new problem, 4.5 plus 0.62 times 10 to the, my new power is 8. So let's combine this. 4.5 plus 0.62. 6.2, not what 5.12. So 5.12 times 10 to the 8th power is my final answer. Now, like I said earlier, with multiplication and division, these do not need to be the same size, because I can rewrite my problem 4.6 times 2.1 times 10 to the 9th times 10 to the negative 3rd. And remember, when you have things that have the same base, which is 10, I can add the exponents. So this chunk over here becomes 10 to the, 9 minus 3 is 6. And I just have to multiply these. So 4.6 times 2.1. 4.6 times 2.1 is 9.66. And I am done. Division works similarly. I don't have to have anything to be the same power. All I have to do is divide this and divide these. And remember, when you're dividing things with the same base, they go to war. I've got 10, 10, 10. I've got 9 of those on top. 10, 10. I've got 4 of those on bottom. They go to war, and I have 5 10s left on top. And I'm going to do 7.2 divided by 3.2. 7.2 divided by 3.2 is 2.25. And so that is just my answer, 2.25 times 10 to the 5th. All right, on to some geometry. So use the figure to find the measure of each angle. So I'm going to fill in what it gives me first. So it says the measure of angle 4 is 132. And before I even answer any of the other questions, I'm going to fill in everything else that I have. So angle 1, you'll notice, is a vertical angle. They shared this vertex. So it is also 132. And remember, on these diagrams, because they're parallel, if I were to cut this line right here and I pick it up and slide it down and set this dot on top of this dot, they'd line up exactly the same. So that means 4 would land on top of 8, which would give me 132, and 1 would land on top of 5, which would give me 132. So I'm halfway labeled with this picture. Now I just need to figure out the rest. Remember that straight lines, here's a straight line, these two angles add to 180. So if that angle right here is a total of 180 and the bigger portion takes up 132, with my calculator, 180 minus 132 gives me 48. So this angle 2 is 48 degrees. Because of vertical angles, angle 3 is 48 degrees. And if I pick up this dot and I set it on top of this dot, 2 will land on top of 6, so 48 degrees. And angle 3 will land on top of angle 7, which also gives me 48 degrees. And now all I have to do is fill in my angles. So angle 2 is 48, angle 5 is 132, angle 1 is 132, and angle 8 is 132. And you'll notice the similarities. Lots of 132s and a lot of 48s. Angle relationships. So 5 and 4. Remember, this is the interior because it's between my parallel lines, and this is my exterior. So 5 and 4 are both on the interior. So I'm going to choose, whatever I choose is going to have interior. And they are on alternate sides of this line on the interior. So this is alternate interior angles. Okay, and let's clear this. Okay, 5 and 8. Now you'll notice one's on the interior, one's on the exterior. So I can't call it an interior and I can't call it an exterior. But I do see that they share this vertex and only that vertex, which makes them vertical angles. All right. Next is 2 and 7. Now you'll notice that these are both on the exterior. So I'm going to start with exterior. And they are on alternate sides of that line. So alternate exterior angles. And last but not least, 3 and 7. So here's 3, here's 7. This is my interior angle, and 7's an exterior angle. So I'm not going to choose an interior and exterior. They don't share a vertex, so I can't choose vertical angles. But if I were to pick up this dot, cut my intersections right here, and set it on top, 3 would land on top of 7. That's called a corresponding angle. They're corresponding angles. All right, next problem. So how do I go about finding x, y, and z? Remember, y shares a vertex with 65 degrees. If I were to fold along this line, that would land on top of each other. It is symmetrical. So y is 65. And how do you find out the others? Remember, straight lines total to 180. So 180 minus 65 is, let's grab a calculator, 180 minus 65 is 115. So x is 115. And because x and z are vertical, z is also 115. Solve for the question mark. I want to find the last unknown angle in my triangle. So remember, the sum of the interior angles of a triangle is 180. So this plus unknown should equal 180. How do I find that last unknown? Add the two angles that I know. 55 plus 82 is 137. Plus my question mark equals 180. So how do I find that last unknown? Well, I'm going to undo my operation. I'm going to subtract 137 and see what's left. 180 minus 137 is 43. So my unknown angle is 43 degrees. Solve for x. So this is a similar idea. I have all interior angles and they should all total to 180 degrees, but I've got some variables. That's okay. I'm going to write 180 equals the interior angles. What are my interior angles? Here's one of them. So x minus 10 combined with plus my next interior angle, 2x plus 5, combined with my next interior angle of 35. This is now an equation I can solve. I draw my line down my equal sign. There's only variables over here, so this is my variable side. There's only numbers over here, so this is my number side. I'm going to combine all my variables. X and 2x make 3x. I'm going to combine all my number. I'm going to get rid of all my numbers. I need to add 10. I need to get rid of 5. And I need to get rid of 35. And those are being added, so I'm going to subtract. So 180 plus 10 minus 5 and minus 35 is 150. So 150 equals 3x. And when I divide by 3, I get x is equal to 50. And that's all I'm supposed to, 50. And that's all I need to solve for. So my final answer is x equals 50. Solving for the exterior angle. So notice this is the difference. We're not looking for the last interior, we're looking for the exterior. But my process to get that exterior is going to involve finding that inside angle. So I'm going to add these together. 63 plus 86 is 149. And if my two angles are 149, 180 minus 149 is 31. So x doesn't equal 31. Make sure you recognize that my inside angle equals 31. And how do I get that outside angle? Remember, this is a straight line and totals to 180. So 180 minus 31 equals 149. So x, my final answer is 149. All right, last two. So these last few. So these triangles are they similar or not? So remember, to be similar, I need at least two pairs of congruent angles. So as I look at my diagram, this angle is congruent to this angle, that's one pair. And 20 is congruent to 20, so that's a second pair. So I have enough information without solving for x to say that they are similar because they have two pair of congruent angles. use the following are similar triangles. Use proportion to solve for x. So because they are similar, that means, this length is proportional to this length is proportional to this, and this is proportional to this, which is going to help me. I'm going to start with my x. X over, so the small over the big. And x over 4.5 is equal to, okay, now I'm going to write a proportion for two sides that I know, 4 over 6. So I'm going to cross multiply. 4.5 times 4 is 18 equals, cross multiply the other way, 6x. I'm going to divide by 6 and I get x is equal to 3. So I solved my proportion and for x. All right, I must have deleted the last page, so I'm going to, all right. These triangles are similar. So this big triangle and the little triangle formed by the person. Use the proportions to solve the height of the flagpole. So this is an indirect measurement. This flagpole is casting a shadow, and so is this boy. So this boy is casting a 10-foot shadow, and the flagpole is casting an 85-foot shadow, and the person is 6 feet tall. So I'm going to write a proportion. My flagpole height is x. So my unknown height over the height that I do know, so this is the big triangle versus the little triangle, is equal to the entire length of the flagpole shadow, so that's 85 feet, divided by the person's flagpole, the person's shadow. So 6 times 85, I'm going to cross multiply, is 510, is equal to 10x. And I'm going to solve by dividing by 10, and I get x is equal to 51. So the flagpole is 51